Hey guys, how's it going? Today I want to show you a little bit about my robot project I'm doing here. I'm not sure about the name, probably like a seaboard or a square or a sphere board. Maybe it looks like a worm. Could also call it worm board, but yeah. As you can see, we have here special abilities depending on their positioning of the axis, and kind of C shape. On the left you see the spheres as a basic shape, and the whole sphere is divided in 3 sections, like the bottom section, the middle section, and the top section, and in between those cuts and separations we have something like 60 degrees. And yeah, what is the benefit of using this kind of shape? So the basic benefit is, in my opinion, that with this positioning you are able to have a more stable construct from static sides. Maybe flexibility is higher. I'm not sure about that. This is something we have to definitely to compare upon this baby against a ordinary robot 6-arm structure model. And as you can see, it will be adaptable. So you just need to connect more spheres or more axes together, and then you get more flexibility. The question is, what makes sense, or where are the borders, where are the use cases for this? So this is something I'm still trying to figure out today. In my opinion, we haven't seen something like that before. I know that one of the bigger robot companies already had something for I would say like for the Axis 5, for the hand axis, but it is not used anymore, and that's also one of the points I have to figure out why it is not used. What are the benefits, what are the downsides, but at this point of this durability, maybe reachability study, I think it's a pretty nice concept. It's interesting, and I feel that the leverage is not so bad if you look at this positioning, like it is for a normal robot. Okay, it has 8 axes. A little bit more, and probably you would need a 9th axis here to rotate, because if you look in this direction, we can make a straight in this, but not in this. So there would be probably needed something. I can assume, or I'm assuming that for something like turning upside down, that would be pretty awesome. It looks like the flexibility is way higher, and probably also the speed, depending on, yeah, it's kind of coupled connection to this axis. So yeah, from up to down, something. Let's check that. Something like, yeah, something like this. I'm not sure. Check the Y. Yeah, the handle is not done. That's one of the tasks I have to do. I need a good handle system, kind of fiducial, where I can move the whole thing around and yeah, make it better for positioning. Currently, I can just it's kind of move in Blender. The G command is for moving, and the orientation is depending on the axis himself. So it's kind of, I would say, a random case. But yeah, kind of interesting. If you need to go inside something, I guess, yeah, flexibility is way higher, which you always or also would get with a normal robot and attach something to it. That's not in the discussion, but the shape himself and the said it, the way we are moving is very unique. So it's like I said in the beginning, it's more like a worm, snake. Let me dim a little bit the other guys. If you play them, you can see some movements here. So yeah, that's it basically. That's the update from this small project. Basically a durability study for design. And I'm not sure at this point where this whole thing leads. I just let it run and doing something and figuring out what it is we can solve with that. But there it was. Wait a second. There was that kind of movement. I want to say like this, from this position to this position. That's probably sort of upside down 180 turn. I guess that will be the big thing with this kind of model. Okay, yeah guys, thanks for watching, and you know, if you like that kind of stuff, hit the subscribe button and the notification bell, and I hope we're gonna see you next time on this channel. Have a good one.